Good day, viewers. Welcome back to another episode of our Tech Talk Show. The impact of cloud computing on industry and end users will be difficult to overstate. Many aspects of our everyday life have been transformed by the omnipresence of software that runs on the cloud networks. By leveraging cloud computing, startups and businesses are able to optimize costs and increase their offerings without purchasing and managing the hardware and software themselves. Before we begin this episode, allows us to present Mr. Sajad Khan, CEO of Silicon Valley. Welcome, sir. Having you on board is a pleasure once again. Without further ado, let us start.
Okay, so today's episode we talk about cloud computing, and this was one of the show that I had. I had this discussion with the University of New Era University in the Philippines. We had this they call it Hello World webinar, and we talk about this computer, the cloud computing. From the computer department of the University of the New Era. Anyway, so before we begin with the cloud computing, we have to have a little bit more knowledge about how this all things started. There are two types of in the world we are living today. We have the physical world. We call it. Another one is like virtual world. We can call cloud world or virtual world. So. The virtual world is getting momentum for its own. There are a lot of things are going on the virtual world. We talk about the metaverse and some other things, right? So to have all those things, that the brain of all or the back end of all is basically a computing, which is the cloud computing. So we talk about ML, we talk about the AI, all those things basically are right now are possible because of this cloud computing and the computer network that is running today. But the computer, computer is something that has emerged from a very small things like a calculator. Yeah. So from the calculator, the computer came. So let's not talk about these things anymore as we are talking about the cloud computing. So we'll have a little bit history about when this cloud computing or these things has started. I will ask Atif to go ahead on the history, a little bit history of about cloud computing.
The history and evolution of cloud computing date back to 1950s and 1960s. During the 1950s, companies started to use large mainframe computers, but it was too expensive to buy a computer for each user. In the late 1950s and early 1960s, a process called time sharing was developed to make more efficient use of expensive processor time on the central mainframe. In the 1969, when an American computer scientist, JCR Linkleader, helped create the Advanced Research Project Agency Network, the so-called precursor to the Internet. In the 1970s, cloud computing began taking a more tangible shape with the introduction of the first VMs, enabling users to run more than one computing system within a single physical setup. During the 1970s and 1980s, Microsoft, Apple, and IBM developed technologies that enhanced the cloud environment and advanced the use of cloud server and server hosting. In the 1999, Salesforce became the first company to deliver business applications from a website. And in 2006, Amazon launched AWS, providing such services as computing and storage in the cloud.
Okay, so as we see from the 1950s and until 2000, 2006, the cloud computing was not going as a retail part or the commercial level. It was like using as a platform. And mainly, when I was my old days, we study. When I was in AMA, I saw we had, I think, one of the first computer school in the Philippines, and we saw they have a mainframe. So that was 1960s, 70s technology. The one you were talking about, the timeshare and a little bit more. So we used that mainframe. It was like a big thing for the world. So mainframe, IBM mainframe was something that was something that universities should have or something like that, or a big corporation. But today, those mainframes are less powerful than a cell phone. So, a cell phone is more powerful than those mainframe computers. So as we move forward on the cloud computing, many IT companies like even small as our companies and many other IT enterprises right now, maybe around 30% to 40% of the IT companies now are moving from a physical computer to the cloud computing. So as old days, what basically happened, we call it a dedicated server, meaning one computer for each person, okay, or each companies. Yeah. So it will have a username, password, and you manage that one. So it was a bit expensive. So old days, I used to rent computer servers in the past. So I used to rent a dedicated server. But when I see that my client is having a hard time because of I was charging them like $500 per servers, and I was maintaining about 1,200 servers. So when I maintained the 1,200 servers, I was having a lot of hard time maintaining them. At the same time that my clients was paying me $250 to $500, it's also paying for them to have that much. Sometimes my customer are not using as much resources needed. So I think the start of the cloud computing came from there. That you have a pool of data, you have a pool of storage, you have pool of computing power, but people will need or they pay as they use it. So that's how basically AWS or Amazon they started. It's like as you need, meaning a lot of resources are there. It's like a shared resources in the cloud. So if you are using like $10 services, you pay $10. Yeah. You are like using $100 services, you pay $100. So that becomes more practical in our daily lives. Okay, so that's basically how so to get more into that one, I will ask again Alif about what is really the real meaning of the cloud computing.
So coming from the word cloud and computing, of course, cloud comes from the internet. So we usually just practice storing and running apps and data in the cloud as opposed to locally on the computer.
Right. So of course, so that's basically how it is. So what are the feature set? I will ask Isha, what are the feature set or rather feature of a cloud computing today?
So there are 5 features of cloud.
Those are the main component. Okay.
Yes. So the first one is cost management. Next is governance and compliance. Next is automatic and orchestration. And next is performance monitoring. And lastly is security.
So those are the main basically set of core features, basically you can say, of a cloud
Features.
Cloud computing features. So number one, the one a while ago I explained, was more or less is when we shift it to the cloud, like in the past I used to have a web servers and I used to rent a lot of servers as well. So the cost was one of the major factors. So that's where it minimizes a lot of cost, and of course the compliance become more easier. The automation and like the one a while ago we talked about the machine learning and the artificial intelligence and Neuralink and other things that's automation, like deep learning and learning platforms, and all those things become very optimized today because of our cloud computing, and of course it can do a lot of performance monitoring. So we need to have like we can monitor our storage, can monitor our networks, we can monitor our applications, computations, and at the same time these things can be divided. Unlike before, you cannot. So you have one dedicated computer, which is where we have all the resources are just there. So you cannot have, like, if you need example, you have 16 gigabyte of memory, you want 64. In the past, you cannot do that. Maybe your maximum for your computer is only 32 gigabyte. So when you scale, when you have your edge that your company need more resources, either you have all this data to transfer to another computer, which is more better or more faster. But today, no. This is the cloud computer is just like a elasticity. So it's like elasticity, meaning as you need, you can have expanded, and then when you don't need it, can be minimized. So it's like elasticity today. In the past, basically we talk about cloud today, but in the past we are talking elasticity computer basically, to be honest. So that's basically how it was. But later on they changed the name to the cloud basically. So that's basically are there. So the another thing is for the cloud is the infrastructure, like Azure, like Google Cloud, like the Amazon. What they do is they're mixing and matching right now with the software and hardware in such a ways that it becomes like the internet. When we talk about a cloud, basically in our year 90s, we basically cloud is basically like internet itself is a cloud. So you go to your Google today and you search and you get lot of data, a lot of resources from shared from different people. Like our website, maybe there is data in your website, then when you search in the Google, and it will just simplify it and make the search result and show it to us. So those are like a starting points of a cloud understanding. But today we go more beyond. We have the VMs, we have the Kubernetes, we have the serverless, we have many other things that are gaining their own ways of they're developing a lot of things on the cloud right now. So that's basically are the ways things are being developed. So I will ask Atif to talk about how does cloud computing work.
It starts with client devices. Client devices can access data in cloud applications from distant physical servers, database, and computers via the internet to explain how cloud computing functions. Next is front-end and back-end. The front-end, which consists of accessing client device, browser, network, and cloud software applications, and the back-end, which consists of database, servers, and computers are connected by an internet network connection. Next is central server. It controls communications between the front end and back end. The central servers uses protocols to speed up data sharing. To control communication between various client devices and cloud servers, the central server makes use of both software and middleware. Lastly is the technologies of virtualization and automation. Through the use of virtualization, users may quickly abstract and deploy servers and the underpinning cloud systems into logical entities.
Okay, so those are the things that makes the user case of the cloud computing. So we have our devices like our cell phone, our desktops, our browsers. So these are the ones we are using in like we are seeing. For example, we have the email, right? So we have, when we go to our browser, we put our username, passwords, and we gain the back end part of our mailbox like Google Gmail, right? So basically, meaning maybe the servers are not here. The servers might be in the US or somewhere else, distributed servers in the cloud. So we don't know where is the server, but we're using our browser. We got login, and then we see our mailbox and our mail there. So that's basically ways these interfaces are working. So a while ago we talked about the hosting and how this was done in the past. So I will ask Alip again to talk about the cloud computing versus the regular hosting, traditional web hosting.
Given the many different services and capabilities of the public cloud, there has been some confusion between cloud computing and the major uses, such as web hosting. While the public cloud is often used for web hosting, the two are quite different. A cloud service has three distinct characteristics that differentiate it from traditional web hosting. Number one, users can access large amounts of computing power on demand. It is typically sold by the minute or the hour. Number two, it is elastic. Users can have much or as little a service as they want at any given time. And final, the number three, the service is fully managed by the provider. The consumer needs nothing but a personal computer and internet access. Significant innovations in virtualization and distributed computing, as well as improved access to high-speed internet, have accelerated interest in cloud computing.
So you see, so there are a lot of difference between these two. But if you are looking at normal people's point of view, a web server doesn't have any difference on the cloud computing. Cloud computing is totally different than a traditional web hosting that we do in the past. And again, so that's there. And one of the major issues in the past was when you talk about sharing a data or sharing a server, many people had issues talking about like the cloud security. So again, they were thinking, okay, we have one laptop, then we have 200 people are sharing one laptop resources. So let's put it this way: this laptop is a cloud computing, and then you have like 20 VMware install or virtualization software install in like VirtualBox and some others on that computer. And people are thinking, what if my data will be shared, or my data somehow will be accessed by the other users? So that was one of the major issues on the cloud security. But day by day, the cloud computing become very stable, and it has all the security measures of that one were really improved a lot. So today people are using about 60% maybe people are using on the cloud now. I think maybe year 2030 another 90% maybe out of 100% maybe about 90% will go to the cloud. So of course the security threat are there, but at the same time the way they structure the data, the way they structure the automation, the virtualizations, I believe that the security of the cloud is going to be more and more improved in the future. But today you see that in the past the bank was one of the things that they talk about. Fintech basically are very afraid of hacking their computer or sorry their data, and because it's all talk about money, right? So and blockchain technology came in and other things are there, but the cloud security itself improved a lot right now, that even the companies or big banks and big institutions are not afraid to move or to shift from traditional computer web hosting from a cloud computing. So of course, beside all those things, there are the major benefit of the cloud computing are cost, speed, and a lot of things. So I will ask Isha again to talk about the top benefits of the cloud computing.
So there are 7 top benefits. The first one is cost, next is speed, next is global scale, next is productivity, next is performance, next is reliability, and the lastly is security.
Okay, so those are the top benefits basically of the cloud. So Alif, can you a little bit elaborate what are those things, and on the I mean a little bit explanation on maybe people will not understand those, so I will ask you to explain a little bit.
So, as said, the first one was cost. So, in cloud computing, it eliminates the capital expense of buying hardware and software.
Right.
Then, in the speed, most cloud computing services are provided by self-service on demand. So, even vast amounts of computing resources can be provisioned in minutes. Typically, with just a mouse clicks, giving business a lot of flexibility, taking the pressure of capacity planning.
Right.
And in global scale, the benefits of cloud computing services, including the ability to scale elastically. In cloud speak, that means delivering the right amount of IT resources, as said by Sir Sajad. For example, more or less cloud computing power, storage, bandwidth, right when they're needed, and from the right geographical location. Next is productivity. On-site data centers typically require a lot of racking and stacking, hardware setup, software patching, and other time-consuming IT management chores. Cloud computing removes the need of any of these tasks, so IT teams can spend more time on achieving more important business goals. And next is performance. The biggest cloud computing services run on a worldwide network of secure data centers, which are regularly upgraded to the latest generation of fast and efficient computing hardware. Next, reliability. Cloud computing makes data backup, disaster recovery, and business continuity easier and less expensive because data can be mirrored at multiple redundant sites on the cloud. And of course, the most major one, security. Many cloud providers offer a broad set of policies, technologies, and controls that strengthen your security posture overall, helping you protect your data, apps, and infrastructure from potential threats.
Okay, so you see, so the cloud computing basically, in a way, solve a lot of problems. One of them, again, you said about the people, IT resources.
Yeah.
So maybe example in the Philippines, let's say in the Philippines, we might not have a certain skill set of the people. Like we might not have in the Philippines, we don't have a good IT resources or maybe the back-end resources people, but maybe in the US they have, right? So this cloud computing fixed those issues. Companies like Silicon Valley, like our company, we need we need a good servers, we need we need a good clouds, and we don't want to hire a local resources because maybe we are not sure about their skill set on the security and other issues. So we look for a very high standard cloud provider. So for that one, of course, we cannot rely on the local resources. So that's one of the problem that it solves. Of course, the local resources, meaning you have your more people to be hired. You have to have in the Philippines, the electricity is very expensive. So maintaining the cost of a rack is a lot expensive than abroad. Even in US is very cheap. So again, what are the common or maybe top cloud provider in the world? Atif.
The top cloud providers today are, starting with Amazon Web Services, or in short, the AWS, Netflix, Microsoft Azure, Google Cloud Platform, Alibaba, and IBM.
Okay, so basically you made a mistake. Netflix is not a cloud provider. Basically, Netflix is the Amazon's biggest customers. Meaning, because of Amazon cloud, we have this Netflix today. We watch a lot of movies, a lot of TV shows, and many other things like Indian shows. So we have this today is a very cheap ways, because Amazon give Netflix a cheaper solution. So instead of having one movie, the one we see, we go to the movie theater in SM and we watch movies, and we see that we spend one movie for like 500 pesos or $10 per movie, and we go as a family, 6 of us, we spend a lot of money for one movie alone. But on the Netflix, you can lay down at your home and you can have all the shows in front of you, and very cheap ways, like my monthly maintenance of less than $10 per month. So that's only this content, or these gigabytes of servers, or these gigabytes of contents, having these HD movies, these 4K movies, and even some of them are 8K movies right now. So this is only possible because Amazon or any cloud or a major cloud provider are giving Netflix a solutions a very cheaper ways. That's why Netflix can do a lot of cheap solutions like YouTube today. We are putting up our videos, and YouTube is making its own encoding. So it has its own cloud encoding servers, where when we upload a video, it redirect to each of these videos into different encoding platforms. For example, 340, 460, 760, 1080p, or if it is 4K or other ways. So basically, these are only possible because of the example on the YouTube is a Google Cloud. So Google itself is a cloud provider, platform provider. At the same time, they also have their own IT services. Why Amazon? I will give you a little example. Why Amazon is having this 2006? Why they open up for the public their cloud computing? Or why do you think that they open up this came into the market? Whereas Amazon was purely a e-commerce platform in the past. They have no knowledge of cloud computing. They have no knowledge of how the computer works in the past, because they were a company like us today, that they were only providing a e-commerce solution to the people. What do you think, Ali? Why they come up with this Amazon web services?
So I think they come up with the Amazon Web Services because their own e-commerce platform having hard time in
that's the main point. So meaning example, we have our e-commerce platform, and when we are scaling ourselves, then we came up with a lot of problems, because we have these physical servers, then we have this backend database, maybe we put up another servers, we need more database, we put another servers, then all these servers, then when we are trying to back up the database, we have a problem. Then one of the hardware failed, one of the hardware died. Like for example, we have one hard disk corrupt and it dies. Then a client data of that certain hard disk was erased. So they will try to recover those in a different ways. But the problem is, end of the day, it was very big problem for all the companies in the world. So Amazon, when they were trying to scale by themselves to have their e-commerce was taking momentum, is getting a lot of customers. And then when they wanted to scale their e-commerce platform, they were behind because they don't have the cloud computing. So what they did is they were saying that, okay, my problem is everybody's problem. Today, what problem I'm facing, everybody in the world might be having a problem. So why not I make my own solutions for that one? And while I'm growing, I also lease this to other people so that other people will not have same problem that Amazon was facing during the time. So Amazon come up with that one. So they come up with this elastic server, they call it that time, because they came from a physical servers, so they can scale. So they put it ES2 before they put it ES. So elastic server. So they later on, now we call it Amazon Web Services, but before they call it elastic server. So Amazon came in, then later on when the cloud computing take its step and it become very, very popular in the world, then Microsoft, of course, the competitor of Microsoft, of course, is a giant on the software company. IBM, then Google came later, then Alibaba is the child right now, meaning that then there are other, the Huawei and other companies in China is trying to compete and come up with with their own cloud computers. At the same time, these companies like Amazon, right now they have their own server chips set up by themselves, meaning they even have their own chipset designed specifically for their servers. So they don't really sell outside, but for their own servers, they are also trying to save cost on their hardware cost, so that they can have more people can be coming up more cheaper ways. Even Azure basically is going for their own hardware designs. Even Alibaba has their own design. IBM has their own chipset design. I mean the CPU design for themselves, and also how they were going to scale down. So they have their own rack, they have their own ways of distributing their memories, their storage and other types of data they today use for the customer. And then in the past there was only CPU for computing. CPU was basically designed for taking a task, computing. Then later on we talk about is the CPU added that we call it the multitasking. So then it comes multi-threaded. So multitasking was there, then the multi-threaded came because the more resources need to be shared. Okay, so that's basically how the chipset was designed in the past. For a general, we call it right today, we call them as a general purpose. We talk about in the past, right? We talk about the efficient core, we talk about the performance core, right? But in the past there was none. So these companies today, even going beyond a simple chipset designs, they're not doing it anymore. What they're doing is, one company maybe is focusing more on machine learning. So their chipset or their CPUs are designed specifically for that purpose only. So there are supercomputers. So there are supercomputer built by some companies. So what they're doing is they're also doing their own ways of developing those things. So anyway, so we'll not talk about that things today anymore. But what the reason why I'm saying is things getting cheaper because companies like Amazon having their own cloud ARM based server solutions they're coming up with it. So there is the new companies 2019 I think they started a new company, server chipset. They only focus on server chipset. So there's the Ampere, one of the companies that developing the chipset right now. So right now Amazon is using them, Azure is using them, Google Cloud is using them. So they are only focused on the server side chipset design, CPU design. Yes. So they're designing the CPUs for server only, not like our what we are seeing in front of us, our desktop. So they don't design for any kind of things on the laptop. Anyway, so those are Intel, are AMD and ARM, some NVIDIA, some other companies are designing a general purpose CPUs right now. Of course, even themselves they have we call it today SoC, right? Yeah. It's software as service. Sorry, the chipset in a anyway. So we will not talk about this anymore today. We go for the types of cloud computing. So who can, Alif or Atif, Isha, you can talk about the types of cloud computing.
So there are three types of cloud computing, which is the public cloud, which it has third-party cloud service provider, which delivers their computing resources like servers and storage. And the second we have is the private cloud, which is mostly used for businesses or organization. And next is the hybrid cloud. The hybrid clouds combine public and private clouds. all
Okay.
at once together.
Okay, so those are the types, basically three types of the cloud computing right now exist. One is public, one is private, one is hybrid.
Yeah.
I think for our the data users, we need to use the hybrid,
Hybrid, yeah.
solutions.
Yeah.
Solutions. Because of the cloud computing, there are also services.
Yeah.
Lot of services comes in. So I will ask Alip to talk about the types of cloud services.
So there are a lot of types of cloud services, which is IaaS and PaaS, serverless and SaaS. So first we go with the infrastructure as a service, or IaaS. The most basic category of cloud computing services. With IaaS, you rent IT infrastructure, service and virtual machines, or VMs, storage networks, operating systems from a cloud provider as pay-as-you-go basis. Second, platform as a service, PaaS, refers to cloud computing services that supply on-demand environment for developing, testing, delivering, and managing software applications. PaaS is designed to make it easier for developers to quickly create web or mobile apps without the worrying about setup or managing the underlying infrastructure of servers, storage, network, databases needed for development. Next is serverless computing. Overlapping with PaaS, serverless computing focuses on building app functionality without spending time continually managing the servers and infrastructure required to do so. The cloud provider handles the setup, capacity planning, and server management for you. Serverless architectures are highly scalable and event-driven, only using resources when a specific function or trigger occurs. Next is software as a service, or SaaS. Software as a service is a method for delivering software applications over the internet on demand and typically on subscription basis. With SaaS, cloud providers host and manage the software applications and underlying infrastructure and handle maintenance like software upgrades and security patching. Users can connect to the application over the internet, usually with a web browser on their phone, tablet, or PC.
Okay, so you can see that there are a lot of cloud services are coming up. Those are not existed in the past.
Yeah.
And the cloud computing, the you can see the Google Docs, the Microsoft 365 we call, but it is a Microsoft Office extension to the cloud. This will not be possible today to use our emails, calendar, Skype, WhatsApp, Zoom, whatever we talk about our daily lives, what we're using, like Viber and all the other things, cannot be possible if the cloud computing will not have today's stability, or it will not be today.
Yeah.
So what do you think will be the future of rather the cloud computing? What might be the extension, or what is the future of the cloud computing? Alip, do you have any idea?
I think the future of cloud computing, that you will as you said, that 90% will use cloud computing in the future. More will use cloud instead of the locally.
Yeah, so the cloud computer will expand its own ways, but the problem right now today with the cloud computer is the location, the geolocation.
Yeah,
That's the problem with the cloud computing. Meaning, example, you are watching Netflix and the Netflix servers are in the US,
Yes, yeah.
so there will be a delay.
Yeah.
Delay,
The
right?
bandwidth.
So the
Bandwidth.
the bandwidth use and delay as well. So we can fix that. In the past, what we did is we put up a cache server, we call it. So because of the cache, it uses less bandwidth because it will download locally the servers. The problem is, what if the same services today in the Philippines right now we are watching a certain movie, and that movie somebody from Germany want to watch the same movie. So that's another problem. It will download again to that area, and it is going to. So that's basically the current problem of the cloud computing. So to solve that problem, there is new type of computing coming. What is that? So that is the edge computing, we call. So in the past we have the similar problems. So the edge computing basically is not as service like cloud computing, but the edge computing are there to solve the problem of the latency.
Yeah.
So number one, the problem of the latency and the data availability on the local level, meaning on the data will be connected to the nearest computer.
Yeah.
So that's basically, again, it's more or less a latency problem.
Speed.
Problem that speed and also not only speed, the latency, but also the distributorship,
Yeah.
the the distribution network. So,
Yeah.
single data, when it will be needed on a certain areas, it will be already copied and there. So, of course, there will be, I'm sure there will be more complex issues are there and to be solved by those big cloud providers. And they're coming up with more solutions to have not only the latency, but the edge computing. So, and that's basically today's problem, meaning it is going to come tomorrow.
Yeah.
So they're working on that edge computing today, and it is coming tomorrow. And later on, the biggest challenge we might face, or the biggest problem that can be solved, will be the quantum computing. So that might be something that is ought to look at. And we will talk about the edge computing on our next, on some other episode, and also we talk about the quantum computing. So we'll end our episode today by for the cloud computing.
So that concludes our today's episode about cloud computing. Once again, thank you, Mr. Sajid Khan. And thank you, viewers, for watching, and have a nice day.
Hello world! Please don't forget to like, share, subscribe, and hit that notification bell for our future videos.
And if you have any further questions, please comment down below.
That concludes for today's video, and this is Tech Talk Show.